All right. There we go. This way. All right, so solving by collecting like terms. Right now you have a sine of x and a negative sine of x, and they're on opposite sides of the equal sign. Technically, they are like terms because they're both signs of x, so you can put them together. So if you have one on one side that's positive and one on the other side that's negative, you can move them over by adding and subtracting, doing the opposite signs. So it's up to you. Do you want to move the sine of x as positive over, or do you want to move the positive one or the negative one over towards the positive? Move the negative one? All right. So if it says negative sine of x, you're going to add the sine of x. And if you have a sine of x and you're adding another sine of x, we end up with 2 sines of x, yeah. So this will be 2 sine of x. And then we have plus the square root of 2, and this is now equal to 0. All right, and this actually turns into the type of equations that you were solving yesterday, right? So how would I solve this? Don't divide first. Divide second. Subtract the square root over. So you'll have a negative square root of 2, and then go ahead and divide by 2.
So does this work in reverse MDOTs that we've learned for years?
Yeah, anytime you're solving an equation, it's reverse of order of operations. Every time. So where is the sine of x equal negative square root of 2 over 2? Grab your unit circle if you need to. Here's mine over here. 7 pi over 4, yes. And 5 pi over 4. So that means your x in this case is 5 pi over 4 and 7 pi over 4. So if you were to take 5 pi over 4 and plug it in here to the x here and the x here, this side of the equation would be the exact same as that side of the equation. All right, I'm going to do another one with you first before I have you try. So we have cosine of x equals 3 cosine x minus 2. So what are our like terms for this one? The cosine x's, and we can put them together, right? So do you want to move the 1 or the 3 of them? You can move the 1. Technically, it's actually faster to move the 3, right? Because this side has the minus 2 with it. So move your cosines over. So imagine if this was just an x and this was a 3x, it'd be easier to move the 3x over, right? It doesn't matter. You just might make an extra step for yourself. All right, so we have cosine x minus 3 cosines of x. How many do we end up with? Negative 2. Cosines of x, there was 1 here, minus 3, and 1 minus 3 is negative 2. So negative 2 cosine of x is equal to, what's left on this side is just the negative 2. Next step, what would you do to keep solving? Divide by negative 2. So we'd have cosine of x is going to be equal to a positive 1. So where does cosine positive 1? Think about your unit circle. 0 and technically 2 pi. And so this is where you should check like the directions if it gives you the interval, right? And it says, hey, which ones could it be equal to? But for right now, just go ahead and say 0 and 2 pi. 0 and 2 pi. So I don't think I put specific interval directions on this. All right, go ahead and try this next one by yourself. See what you come up with.
So this is like just straight up solving for x, except with that whole little bit extra stuff.
Yeah, it's you're solving an equation, and these happen to be trig equations. So in Algebra 1, you solve linear equations.
Yeah.
Then you learn how to solve quadratic equations, right, by factoring or quadratic formula. Then you learn how to solve a polynomial equation or an equation with the square root or equations with squares or things like that in them. We've learned how to solve rational equations. So it's just different kinds of equations to solve. So these are trig equations.
This is like just straight up stuff we learned in pre-algebra, just with giving signs and symbols in it now.
Yeah, so all of the algebra that you've used in the past to solve equations are still valid, and
it's all the same stuff.
It's very similar.
Right.
Yes.
Yeah.
But the only difference is now instead of just like an x, we throw in a sign of x.
Yeah, and then we slap in one more answer on the back end.
Yes. Yep. And so the hard part will be recognizing which one of those methods that you've used in the past to help you out here. Absolutely. So I didn't finish writing that, did I? All right, what'd you get for your two answers here? Pi over 3 and 2 pi over 3, absolutely. So we ended up with subtracting, right? So we had 6 sine of theta. Divide by the 6, so we have 3 square root of 3 over 6, which simplifies to square root of 3 over 2. And then where is the sine square root of 3 over 2? At pi over 3 and 2 pi over 3. How'd you do?
Good.
Yeah, this one?
Yeah, and I didn't know what that symbol was.
Yeah, so you simplify those constants in the front. So essentially this is saying 3 times the square root of 3 divided by 6. And because it's multiply divide, you can change the order and do 3 divided by 6 times the square root of 3. And 3 divided by 6 is 1 over 2. So that's how you have the 2 going. All right. So if you have like terms, you can combine like terms and continue to solve that way. Any questions on those first 3? What do you think about those? Okay. All right. Well, we are going to move on to another method by using square roots. When do you use a square root? When you have something being squared. If you need to get rid of a square, you take a square root. The same thing is true if you're working with trig functions. If you have a squared term and you need to get rid of the square, you take a square root. So in this first equation, we have a tangent squared. So we'll have to get rid of the square by taking a square root, okay? All right, before you take the square root, though, you want to make that look a little bit nicer, yes? What do we have to move over first? The 1, so we'll add 1 to both sides, and then also get rid of the 3, so divide by 3. If you're okay doing that at the same time, I am too. So we'll have a tangent squared of x equals 1 over 3. And whenever you see that tangent squared like that, that is saying you have a tangent of x times a tangent of x. You have 2 of them being multiplied. So you have a tangent of x squared. And so you can get rid of the square by taking the square root. So square root this side, square root this side, you'll be left with the tangent of x over here. And then we have some interestingness happening, yes? Square root of a third. Do you remember what happens when you square root a fraction? Yeah. Borrow away. Sorry, what happens when you square root a fraction? You have to rationalize. Before you rationalize, though, the square root of a fraction, you can think about the square root of the top and the square root of the bottom. So I would think about this as the square root of 1, which is 1 over the square root of 3, which is square root of 3. And then technically you do have to rationalize this, right? Because you have that square root in the bottom. So 1 over the square root of 3 will rationalize as square root of 3 over 3. And then one last piece, whenever you take a square root, what do you have to remember to include? Plus or minus. So technically it's square root of 3 over 3, but it could be positive or it could be negative. Because when we go back and plug it in and we square, positive square roots are positives and negative square roots are positives. So we don't know if it's the positive or the negative, so you have to include both. So the question is where is the tangent equal to the square root of 3 over 3? Either positive or negative. Doesn't matter. So instead of 2 answers, we're actually going to have 4. And then this is where this information is helpful, yes? Square root of 3 over 3 was when we had 1/2 on the top and the square root of 3 over 2 on the bottom. So remember, tangent is sine over cosine. So it's where the sine is a half. Oh, half. So pi over 6 and all the over 6's, right? So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So x in this case is any sort of pi over 6. 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right, how do you feel about these square roots? You want to do one more together? So we have 2 sine squared of x minus 1 equals 0. So because there's a square in this term, I'm going to have to take a square root to get rid of it. Before you take the square root, though, you want to get that sine squared part by itself. So we have to move over some things, yes? So what are we moving? The negative 1, make it a plus 1, and then get rid of the 2, so divide by 2. So we'll have sine squared of x equals a half. And then don't get fooled. This is not where sine a half, right? This is where sine squared is a half. So in order to figure out where sine squared is a half, you still have to take the square root. Still got to square root this. So remember, our answer could be plus or minus. And then the square root of a half, you can square root the top and square root the bottom. What's the square root of 1? 1 square root of 2 is just square root of 2. And 1 over the square root of 2 would actually rationalize to square root of 2 over 2. That's where knowing how to rationalize things real fast. Remember, like that very first couple days, I was like, we're going to get this rationalizing down. And so where is the sign of x either positive or negative square root of 2 over 2? You probably don't even need a circle with this one, right? At all the over 4s. Over 4s are where you have square root of 2 over 2s. So pi over 4. What's the next one? 3 pi over 4, right? 5 pi over 4. And 7 pi over 4. There we go. All right, go ahead and try that next one by yourself. The cosine squared. This one didn't have to be rationalized, did it? When you took the square root, it was just really nice. Square the top, square the bottom, then you were good to go, right? All right, what did you get for your x's? There were 4 of them. pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So whenever you're taking a square root, most likely you're going to have how many answers? 4. 4 answers there. All right, what do you think? Taking square roots, yes, no?
Good up until that.
What?
I said good up until that.
Did you want to see that one real fast?
Yeah.
So, well, I probably can walk you through, right? So you add 3 and divide by 4.
Yep.
And when you take the square root of 3/4, it's the square root of 3 and the square root of 4, and the square root of 4 on the bottom will simplify to a 2. So it's plus or minus square root of 3 over 2. And those are just the cosine values. So you find where cosine square root of 3 over 2 or negative. All right.
I got there and just kind of did it.
Gotcha. You ready for these last ones? Solve by our favorite thing in the entire world.
Stop it.
Factoring.
Stop.
Factoring. We love to factor, don't we?
No.
Nah. It'll be all right. Solve by factoring. So here's this first one. You have a bunch of terms. You have a cotangent of x, a cotangent squared of x. Those two are technically being multiplied together, and then it equals a cotangent of x. And so whenever you factor, you always want to set it equal to 0. Always, right? No matter what you're doing, set it equal to 0 so you can use what we call the zero product property after we're done factoring. So would you like to move over just the cotangent or the cotangent with the cosine? You want to move the cotangent with the cosine over? Okay, so if you move this over here, it will be positive on this side and negative, right? You're just subtracting it over. Technically, this is a positive term, and you move the whole thing at once by one big subtraction, all right? So we would have 0 on this side, a cotangent of x here, this one, and then subtract that whole term over. Subtract cotangent of x, cosine squared of x. So we took this term and subtracted it over there. Yes?
So you said that the cotangent is being multiplied by cosine.
They're being multiplied, yes.
Couldn't you just divide the cotangent?
If you divide by cotangent, you're actually going to divide out solutions. Okay? And so you can technically divide by cotangent as long as you pick up whatever solutions you divide out. And sometimes they're not as obvious. Okay? Okay. But that is a good thought. But yes, whenever you divide by something with a variable and you simplify it, there's a chance you're simplifying out solutions. So you just have to be really careful. So we just took this term, moved it over here. And when we moved it over, it was a positive on this side, so it's a negative on the other side. All right, kind of weird, yes? Very weird. Just kind of strange.
Is it possible you can move it over?
You can move this one over? Yes, and if you move this one over, it would say this minus cotangent. But you'll still get the same answers in the end, and it actually still factors pretty much the same way. All right, so we are going to factor, and these two terms that we have, there's only 2 terms here, have something in common. What do they both have? They both have an x, but we have to be more specific because things are happening to the x's, right? The cotangent of x. They both have cotangent of x's. So we're going to factor out a cotangent of x, and then in our parentheses, we'll have what's left over. So if you have a cotangent and you take out a cotangent, what's remaining? A 1. Just like if you had an x and you took the x out, there'd be just a 1 left. Same thing. There is a 1 here, and then a minus. And if you take this cotangent of x out, what's left is the cosine squared of x. And this is still equal to 0.
Why would you do that?
Yeah, what would you do?
Because how is the cotangent supposed to be?
So what we're going to do now is we're going to use the zero product property. So remember when you factor things, when they're equal to 0, it's whatever makes the factors equal to 0. Do you remember that? Whatever makes each of your factors equal to 0. So because you take out the cotangent of x, it's whatever makes the cotangent of x equal to 0 will make the whole equation 0. And whatever makes this piece equal to 0 will make the whole equation 0.
But how would you pull the tangent out of the cosine?
I didn't pull it out of the cosine. It's being multiplied by a cosine. So because they're being multiplied, I can divide it, factor it out. So we have these two pieces now that could be equal to 0. And if this one's equal to 0, then it's a solution because the whole thing will be 0. And if this piece is equal to 0, then the whole thing will also be equal to 0. So we're going to solve each of these equations separate from each other. So where is the cotangent equal to 0 at? Cotangent is cosine over sine. So it's wherever the cosine is equal to 0, right? So cosine equal to 0 at pi over 2 and 3 pi over 2. Y'all okay with that one? Pi over 2, 3 pi over 2. And 3 pi over 2. So we have two solutions so far. So if you were to take these and plug them in, this side would be equal to that side if you did all the evaluating. And then over here, we have to solve this equation, which we actually just learned how to solve, didn't we? So you can subtract the 1, right? Technically, there's a negative, so we would divide by -1. So we would have cosine of square, or cosine squared of x would be equal to a positive 1, wouldn't it? Subtract 1, divide by -1. So take the square root, so it's where the cosine of x is equal to plus or minus 1. And where does that happen at? Yeah, I just put them in order. Over here at 0, right? And then at pi, that's when we get the -1. And then technically you could put 2 pi, right? Because I haven't put a limit on this interval. So 2 pi would work as well. What was that? Solve by factoring. A little bit trickier, yes?
It's not trickier, it's just like
More steps, yes. A lot more steps. All right, what questions do we have on this guy?
Do you remember like the other way to factor?
Yeah, we're going to do it right now.
With the big X.
Yeah, we're literally next question. You know where we're going.
That was my favorite.
Remember we factored another way, not just GCS, right? There was another way to factor when you had a trinomial. Right.
Yeah, that was my favorite way to factor.
Well, good, because we're going to do it.
Separated into two parentheses.
Mm-hmm.
Oh.
Yep. By the way, there's one small little tidbit with this question, Beth. That's like FYI, right? At these two places, at 0 and at pi, and if you don't catch this when you're solving, I'm okay. This is just kind of, hey, FYI. At 0 and at pi, technically the sine is equal to 0 as well, right? We picked them based off of cosine, but technically the sine is equal to 0. Technically, when you plug them into a cotangent is cosine over sine. And so these two are technically not solutions because they would actually make the equation divide by 0. Do you see what happened there? It doesn't happen very often, but if you were to plug those back in, the cotangent is undefined at these two places. And so if the cotangent's undefined there, technically they're not solutions. Okay? It does not happen very often. This is just kind of one unique one, so I'm just going to point it out. If you don't see it, though, it is like literally this much of importance in terms of the whole, can you solve this by factoring? Yeah.
For the one that we just solved, we want to also include 2 pi.
Go by whatever the interval says at the top. Most likely it'll say just include one or the other, and I don't have an interval up there, so just go with 0 for now.
So we don't write down 2 pi.
If you don't write 2 pi, that's cool for now, yes. Mm-hmm.
So how do we know that those two are undefined?
Because technically, if the cosine is positive or -1, the sine is 0. And if you think about the fact that we have a cotangent is cosine over sine. And if the sine is 0 at these spots, we would divide by 0.
Yeah.
So technically they're extraneous solutions is what's happened there. But I'm more concerned about can you get the factoring down as opposed to did you notice that those two at the very end. So not a crazy big one. All right. Your favorite way to factor apparently. Yes?
It's the easiest way to remember.
The easiest way to remember. I don't know. This one has a 2 in the very, very front of the squared term. So maybe not. So you can think about this as 2x squared minus x minus 1 equal to 0. Instead of thinking of them as signs of x, just think of them as x's by themselves and solve this by factoring. And you'll get really close to your solutions. So do you remember how to factor this trinomial? You are going to use the big X, right? And typically it's whatever numbers at the end, right? And whatever numbers here, they multiply to be this one and add up to be that one. But if there's a number in the front, you have to include it in, right? So it's 2 times negative 1. So we'll include that 2 in with the negative 1. So they multiply to be negative 2. And then they'll add up to be negative 1. That number here, the b value, essentially. So 2 numbers that multiply to be negative 2 add up to be negative 1. 2 and 1. And which one's negative? Negative 2. So this would factor, right? X minus 2, x plus 1. And if you remember, technically when you multiply the 2 in, you have to go back at this point and divide it back out. So both of these numbers get divided by the 2. So here we have 2 divided by 2, so negative 1. And on this side, 1 divided by 2 is still just a half, right? Now, I didn't put my x's in at this point because remember, it's not an x. Technically, it's a sine of x. So technically, in the factors, it's sine of x minus 1 and sine of x plus a half. So this factoring still works, except for instead of just an x variable, it's a trig function. There's a sine of x in there. There could also be a cosine of x or a tangent of x instead. And then you still use that zero product property to continue to solve. So this one is where is the sine of x minus 1 equal to 0 at? So we're really saying where is the sine of x equal to a positive 1? And then we just say where that happens. Pi over 2? Sine of x, positive 1.
Yeah.
At pi over 2? Is that it, or is there other places? That's it. All right. And then on the other one, sine of x plus a half, where is that equal to 0? Because we're actually wanting to know where is the sine of x equal to negative 1/2, right? Negative 1/2. And you said that happens at 7 pi over 6. And, I'm going to run out of space. 11 pi, oops, pretend like there's a pi there. 11 pi over 6. So this equation had 3 solutions. So we've seen equations with 1 solution, we've seen them with 2, we've seen them with 3, and now we've also seen them with 4. So you really don't know how many solutions there are until you get into the nitty-gritty of solving, right? All right. You want me to do this next one with you? And I'll leave the last one for you to try on your own?
Yeah.
All right. Taking a look, we have a tangent square root of x minus a square root of 3 tangent of x equal to 0. Now, whenever you factor, it has to be set equal to 0. So they really kind of helped us out and got us started on that, didn't they? Now, looking at this, are we going to use a big X to factor, or can we just use a greatest common factor? Greatest common factor. If there's only 2 terms, you're going to want to go with a greatest common factor. So what does a tangent square root of x and a square root of 3 times the tangent of x have in common? They have a tangent of x in common. So if you have a tangent squared and you take out one tangent, you'll still have a tangent. So we'll have a tangent of x left in that first term. And then if you take the tangent of x out of the square root of 3 tangent of x, you'll just have a square root of 3. And this is still equal to 0. So your two pieces here is where is the tangent of x equal to 0? And where is the tangent of x minus the square root of 3 equal to 0? So first one, tangent of x equal to 0. Well, tangent is sine over cosine. So to get tangent equal to 0, the numerator has to be 0, so sine has to be 0. So where is the sine equal to 0? Pi? 0. And technically 2 pi, you can add it or not add it at this point because I didn't give you an interval. Most times they say 0 between 0 and 2 pi, but you don't include 2 pi. All right, and then the next one, this is technically where is the tangent of x equal to a positive square root of 3, right? Move it over. Positive square root of 3. Well, that is one of our possible options, isn't it? If you look in your top corner, square root of 3. So we have the square root of 3 over 2 is going to be the one on the top, yes? So that will be the sine value because sine is on top for tangent. So where is the sine? The square root of 3 over 2. So that happens at, where's the sine? Sine, I heard different values there. Sine is pi over 3 and 4 pi over 3. Yes? Where's 4 pi over 3? Down here? Well, that's negative though.
That's negative.
Yeah. Sine's negative down there, isn't it?
Yes.
Yeah, so that one's not it.
2 pi.
2 pi over 3. Okay. 2 pi over 3. The sine for the tangent, right, to be a positive square root of 3.
Yeah, exactly. Everything down there is both those.
Oh, I got a little distracted by the sign, didn't I? Yeah. Yeah. Hey. All right. Okay. So let's talk about. Let's talk about why it is 4 pi over 3. It's a tangent value, right? And for tangent to be positive, both the sine and cosine have to have the same value. So we were hung up on the sine being the square root of 3 over 2. It's where the sine is either positive square root of 3 over 2 or negative, but the cosine has to have the exact same value, right? So tangent is positive in Q1 and Q3. I would have got that wrong. Yep. You even said the right answer. I was like, no, that's not it. Yeah, that tricked me up a little bit. All right, 4 pi over 3. Does everybody understand why it is 4 pi over 3 instead? Okay. I did. I got too focused on just the sine portion of it, didn't I? I didn't remember that it was technically a tangent. All right, y'all want to try the last one by yourself, or do you want me to do it with you? You want to give it a shot?
Yeah.
All right, give it a shot. right, this one was easier to factor, right, because you didn't have a number in the very front. So that meant there wasn't any multiplying you had to do in. You didn't have to go back and divide. So two numbers that multiply to be -2 and add up to be +1. 2 and -1. And so your factors were, instead of just x, cosine of x, right? Maybe. Cosine of x plus 2 and cosine of x minus 1 equals to 0. And so from this first factor, you were looking for where the cosine was equal to -2. Where's that at? Cosine -2. That is nowhere, right? Yeah. By the way, cosine, think about a cosine graph. What's the highest value on a cosine graph? 1. What's the lowest value? -1. Can it get to -2? Not unless there's some shifting up and down, right? And this is not a shift. This is just cosine, no shifts, right? So cosine of x can never be -2. And so this won't happen. Never. So there's no solutions from this piece. Over here, this one, we have cosine of x equals +1. That does happen, and that happens at 0, and you could include 2 pi or just put 0, right? Because 0 and 2 pi are the same. So it is possible as you're working through these that you get a piece that there's no angle that will give you that value.
Way to let us know that man got not messed up in the kid.
I did it the other way, and I was like, wait a minute, that don't seem right. And I did it again. I'm like,
Way to let us know.
Well, why would I let you know? See, you'd be mathematicians now.
Okay, no, it's not sitting there stuck.
You're like, I got this one. This one's good. And you're like, did I factor it right? No, I think I'm good. Yeah, so sometimes when you're working some of these problems, you could have no solution. It's possible that no angles will make that happen. All right, so your assignment is just the next page. It's 1 through 10. So it's just page 27, 1 through 10. And you have just over 15 minutes to get started in working class, and I have solutions. So as you're working, if you want to check your answers with me, we can do that. Or if you have questions in general, we can go over those also. Yeah.